So taking that into account, I just decided to build some case study rooms and analyze them for smaller sizes, for bigger sizes, and so on. So here are some of the parameters. So when analyzing that, I have used lamp lumen maintenance factor as provided by the manufacturer. And then I use the luminary maintenance factor as provided by the manufacturer if it's available, or if it's not available, again, you know, I refer to that particular table from 1680.4 standards. I look into the oil prices as a GST inclusive, because someone's going to pay a GST in the end of the day. So as we're kind of aiming to find out economics of the LEDs, we have to be aware that the end user is going to pay energy prices, and it's all going to hit an end user, and GST is one of the factors. I allow air conditioning impact of 20%. What that means is that if you've got a lighting system which is producing a lot of heat as a waste product, this heat has to be removed from the building. What it means, the air conditioning system has to work harder in order to remove this particular energy, to remove this heat from the building, and that impact is 20%. That means if I'm burning 1 kilowatt of power due to electrical lighting system, you know, 200 watts in addition has to be consumed by my air conditioning system. My apologies, something happened. I base operating hours of annual operating hours 3.5 thousand, annual inflation 2%, maintain luminous flags are required to achieve around 320 lux. Okay, we're talking about the indoor application. Yeah, we could talk about corridors, we could talk about lobbies, meeting rooms, but let's sort of focus on offices. And offices, they are sort of, you know, designed for 320 lux maintain, and I allow 15% of margin because it's very difficult to get exactly 320 lux. I use the energy price of $0.2. That's a net energy price per kilowatt hours, and CO2 emission, that was based on the factor that it's actually well designed for Victoria, I would say. Victoria maybe is even a little bit worse this time, but around 1 kilogram per kilowatt hour. This is the figure you guys have in Victoria. In New Zealand, it's quarter of that, but over there, obviously, it's a little bit more. And I focus on the duration of the test, 50,000 hours. So here is my first model. First model, a room with 4 luminaires. And I would like to maintain certain luminous flux in the end of the lifetime, which is 50 kilo hours. I will obviously allow that 15% more of the margin because it's very difficult to achieve exactly 320 lux. So obviously, you have to be aware that a brand new installation is seriously overpowered. It obviously depends on the manufacturer and the product and so on, but that's the effect what we're talking about. But you want to, in the end of the lifetime, sort of end up somewhere here in this particular room. So it's the approaches in order to compare different products, which are very different. We will be aiming to maintain a similar luminous flux, okay? So we'll be aiming to get that luminous flux in that particular room. You can have slightly different products, more energy efficient, and you can expect the degradation will be a little lower. And somewhere in the end of the lifetime, you want to be within this margin. That was that approach. So here's the smallest possible model, I would say. You've got cubicle office, 2 luminaires, 320 lux, a bit of more, minimum uniformity 0.5, measures from wall to wall, okay? So here is a page showing all the parameters. This is really small office, 3.6 times 3.6, the height 2.7. We're using spacing 2.4. And very quickly you can conclude if this is the type of the office, in order to maintain a 320 lakhs, you need to deliver in the end of the lifetime around 2.85 kilolumen of the luminous flux plus that margin of 15%. Okay, so around 3.2 kilolumen. If you deliver more, you will be just simply wasting power. Okay, so let's kind of see what can you do. So here are the luminaries. Here are the prices. So obviously we've got ETAP, our soft light. We've got alternative cortical rays to the bottom luminary, which is very, very cheap. You've got energy light. You've got something from European supplier. These are different prices. These are obviously initial outputs, which have to be selected very carefully. So in the end of the lifetime, at 50,000 hours, there will be still producing around 2.8 up to 3.2 kilolumen of flux. Okay, so that's what you want to see. The second product, unfortunately, has to be replaced before we can evaluate its output at 50,000 hours, because it's got aging like no other. So if you are dealing with on a small office, you've got 2 luminaries to be installed. You have to pay for the installation. You have to take into account all the factors, and you begin to use it. On that horizontal line, you've got years of usage. You've got your very cheap product right here, and you've got the expensive one a bit over there. Very quickly, you will figure out that this particular product, the cheap one, has to be replaced, and all becomes quite a costly experience. And ETAP is actually green, and eventually it's kind of economical product. All the costs are being accumulated. We're talking about energy costs, as I was explaining them earlier. In addition, you need to address that annual CO2 emission. Okay, how many kilograms of CO2 are you going to produce eventually due to your lighting? Where this is all coming from is that in order to drive your lighting system, you need to supply it with power. And in order to generate that power, obviously you need to burn coal or other fuels, and then obviously you are emitting CO2. So this is the annual, okay? Every year, this will be the CO2 emission per luminary. So we've got 2 luminaries in this model. So this is the ETAP, this is the cheap one. You can see that cheap products are actually harming us quite badly in terms of being responsible for CO2 emission. But the bigger the office space, the lighting systems are more and more efficient, because we are reducing the effect of light being absorbed by walls. Okay, so let's look into a little bit different layout. We've got a slightly larger office. Here are the dimensions, and here is our target of around 2.15 kilolumen plus the margin. We've got 4 luminaries. And here we've selected slightly different products. Now we've selected a very basic U3 from our range. We've got Thorn, we've got Eagle lighting here, and we've got again Plexiform. Then these products are compared against one another. Some prices are being proposed. These prices could actually be more or less accurate, but these are the prices we managed to confirm at the time of preparing the presentation. So here are the initial outputs, lamp lumen maintenance factors, and the output at the end of the lifetime, apologies. So around 2.1, 2.4 kilolumen. It's all good. So let's kind of look into how this is all adding together. So now you can see, obviously we're not dealing with super cheap product, just like we did last time. So there's nothing really which costs around $70 or $90. So they all sort of start from relatively similar price range. Got 4 luminaires. Very quickly you can figure out that having well-balanced energy consumption is the key parameter which reduces cost of luminaires being used in the project. Okay, and in a similar way, if you look into medium and a large office space, obviously you can now start even reducing that particular spacing. You can have luminaires the space of 3 meters. Here are the goals to maintain around 2.9 or 2.8, depending on the room size. And again, this is all to do with maintaining around 320 to 370 lux. Here is an example of what we compared: Legrand, Philips, ETAP, Fagerholt, luminaires with different phases, outputs, and maintain output at the end of 50,000 hours lifetime. So what we've got here, let me observe. So we've got 2 products which are relatively cheap on the left, and we've got 2 products which are a bit more expensive, or significantly more expensive. So how this is all going to end up? If you are designing a green product, pretty much it's no-brainer. These products, even though they are significantly more expensive, they are far more energy efficient, and that energy efficiency is a key factor. Cheap products, obviously, they are attractive for some investors, the people who are really paying for the construction of the building. So they quite frequently will be going shopping and they will be selecting these products, contractors, installers. But if we're to stay green and keep CO2 emission to minimum, this is not the best solution. And a large office, even if you reduce spacing to 2.4, you will figure out that your luminous flux could be even lower, at 1.8 kilolumen. And here again we compare something from ETAP, Eurotech, TSA, Fagerholt products, different prices, really randomly selected products, but we always obviously wanted to select something from ETAP and our maintain output, something that we're really proud of. Here is again a very similar plot showing products and accumulated costs. We've got a Eurotech. Unfortunately, this is the type which has to be replaced because at 40,000 kilo-hours, it's pretty much entering into the very low output zone. So you need to install a brand new luminaire, and your costs are going to be increasing dramatically. Again, if you look into that annual CO2 emission from this particular room, you can see that annual CO2 emission per luminary. Okay, so we've got 20 luminaries in there, so you have to be aware that it has to be multiplied by 20, or your figure has to be multiplied by the number of luminaries you've got in the entire project. This is from what you expect from ETAP. This is the Fagerholt CLO drive. This is the very driver that I spent some time talking about, which got intentionally reduced power when the luminary is brand new, and gradually power is being increased. So this is that particular one, Fagerholt. Okay, so you have to be aware. The longer you use this product, the more and more power is being consumed by these drivers. Okay, So again, that's why I mentioned earlier, we do not necessarily think that CLO drivers are the ultimate solution for our fittings. We prefer to focus on ensuring that we can maintain as much luminous flux as possible. And we've been doing this for almost a decade now. And we've got a record of our research and confirmed by independent testing institutions. So you're probably aware that our new range is the U3. And this is a product which been particularly adjusted to our market. So when you will be browsing with the website, you will see that there is a U3 product, and you can select a U3 range for ANZ, Australia and New Zealand market. So what can you expect from this particular product? So what we've got here is an office space. And on the right side, you've got just a photo of the optics being used by this product. Here's an example of light loss factor 0.88. Okay, this is the first critical parameter. That's what we're confident about. That's what we have proven. That's what it was proven by independent testing researchers. 0.88, if you can use it in the office, you should, definitely should, unless you're dealing with very dirty environment. We're maintaining at our work plane 343 lux, which is relatively close to 320. Uniformity is quite good. And the key point is that you can deliver 343 of the maintained illuminance burning around 2.7 watts per meter squared. Okay, that's the key figure for designers and for people who are designing green buildings. You want to keep this figure as low as possible. Okay, some people are looking into this 0.78 watts per meter squared per 100 lux. I generally do not look into it. I know where this is all coming from, and I know it could be this figure could be reduced if you sort of install luminaries which are not really illuminated walls. To me, this is the key point. How many watts per meter square we're really consuming, because that figure corresponds to the CO2 emission. In terms of glare, you know, that glare it's another story. But if you look into the glare of this particular model, and if you select a luminary for our market, you can expect a well-controlled glare too, with UGR values maximum of 19. A glare of the luminaries coming with this kind of optics it's a completely different chapter. Probably I will be happy to talk about it at the next opportunity. So what we've got now. Here is a figure which is based on all the models and all statistics that I have performed, which shows what is the annual CO2 emission per quarter of the meter squared. Okay, so before I was showing CO2 emission per one luminary. Now I'm showing a CO2 emission per meter square, in fact, 1/4. So in conclusion, I would probably confirm that if you look into the small offices where you got only 2 fittings, generally you will be emitting more of the CO2 emission per year. Okay, your mass of the gas being produced due to the generation of the electrical power will be higher. But then an interesting fact, you see, look into these 2 on the right, the green one and the yellow one. They're all coming from approximately the same office, or exactly the same office space. But the green bar was made from models when we got spacing of 2.4 meters. Not 3 meters by 3 meters, but 2.4 meters. That was the spacing. So ultimately, we actually were placing 25 luminaires inside these office spaces. But on the left, models were done with luminaires where you had 16 fittings only, 3 meters apart. Obviously, you are generally, statistically speaking, you got a chance of producing far more CO2 emission if you are using this approach. Why? Because you really need to deliver quite a lot of power because you are increasing the distance between the luminaires. That's something very, very interesting. Something that obviously it's worth to look at.